Hello everyone, welcome back to my channel. I hope you're having a great holiday if you celebrate this time of year. Today I'm gonna talk about some simple yet very common mistakes that anyone can make when analyzing their data in R. I'll show you the type 5 data cleaning mistakes I saw so many times and I see again and again that my students and clients make. These kinds of mistakes look harmless at first. Your code runs, your model fits, and you even get numbers, but later when your results come out, you see they don't make sense. So you realize something went wrong. That's why today we'll catch them early to prevent from this nonsense. Imagine we have a small data set that comes from a clinical screening study. We measured blood pressure, BMI, age, and physical activity level. So there is nothing fancy here, just this kind of data that people use every day in health research. Right now, everything looks realistic and harmless. So let's calculate the average age of patients. We use mean function for it. So run it. And you see we get NA or null. But why? It's not because the mean doesn't exist, but because one value is missing, as you can see here in the observation. So how can we fix it? First, we get a summary of each variable, including the mean for age variable. And here's the result. You see that we have one null observation for age. So next, we use call_sum function to sum the number of missing observations in each variable. This step is not necessary, but I just want to show you in case you were dealing with a larger data set with more columns and observations. So we get 0 for all of them except for age, which is one missing data. Next code is where we're going to handle it. We're going to calculate the mean of age one more time, but this time we're telling R, hey, compute the mean age for me, but only use patients whose age is recorded. More specifically, the element na.rm means remove missing values or nulls before the calculation. And when it equals true, it means this option holds. Just do it for me. And if it was false, in that case, we meant don't do it. Don't hold this option for me. So run it. And there you go. We get the mean, the same mean that we got from summary with removing null value. Before going forward to the next mistake, I just want to mention something. There are some other ways to handle missing data rather than just removing them, but in this video, we only cover this part that people ignore missing values. In another video, I'll tell you different ways of how to deal with them. So let's move on to the next common mistake in R. You see for BMI variable, we have them all as characters. They look numeric, but R sees them as text because they are within these quotation marks. To fix this, you could have easily removed these quotation marks, but this is not an easy option for when our dataset is very large. Instead, we use another option. We would tell R, treat these observations as numeric, not character. And by running the mean function again, you see we have a number for the mean of BMI this time, 26.7 approximately. So we fixed this mistake of numerics being treated as characters. This often happens when data comes from questionnaires or Excel files, which is very common. So it's good to know how to deal with it. Next mistake is blindly trusting measurements. Here's what I mean. If you take a look at systolic blood pressure variable box plot, you'll see we have one outlier, one entry greater than 800 millimeter of mercury. It's impossible because there is no human being that could have such a high blood pressure. So it is not a rare patient, it's a data entry error. And if we get the mean for the blood pressure, you see the effect of this outlier on the value of mean. It makes it to go very high. So since this outlier is probably a mistake in entry, and it is not an original observation, we could tell R, filter out systolic blood pressures that are less than 300 and get the mean again for it. You see, we have a much more sensible value of 128.6, right? The first mistake is when we misuse categorical variables. Let's see the physical activity variable. Look at the outcome. This variable looks ordered, low, moderate, and high. But R doesn't know that unless we tell it. One wrong way of handling it would be transforming them to numeric. But as I said, this variable is ordinal, not numeric. To fix it, we're telling R, turn it into factor. What is a factor? In R, factor is a data type used to represent categorical variables. So we're telling R, physical activity is the variable we're transforming. Then we explicitly define the possible categories, low, moderate, and high. And we also define their logical order by the ordered elements set as true, which means the order of them is gonna be in the same way that we wrote them from low to high. So we told R not only this variable is categorical, but also ordinal. Now let's see physical activity column one more time. Run it. And you see they're not neither nominal nor numeric. They have levels, right? Easy peasy. And finally, let's get to the final mistake, which is cleaning without thinking, like just dropping rows. This removes patience with missing data. But as I said, getting rid of missing data is not always the best solution, especially in health research, where missingness itself can be informative. Hopefully, I'll show you what to do with them in the next videos. So, up until now, from these mistakes, we learned that data cleaning is a part of the study design, not just coding. And the goal is not to make data look perfect, but to make decisions you can defend scientifically. And that was it. I hope this video cleared out some mistakes that might arise your way. As always, thanks for watching, and don't forget to like and subscribe to my channel. I'll see you in the next video.